Yes, hello everyone. Last time, we stopped at arithmetic operators. We're continuing with operators. Now, our next operator is assignment operators, friends. Operators that perform assignment operations. Let's write it here. I'm calling it runner assignment. We can make it a bit bigger. Assignment operators. Now, normally, the assignment operation is used to assign a value to a variable. So, our very first and most basic assignment operator is the equals sign. Friends, what does the equals sign do? It performs the assignment operation. Its main purpose here is this. For example, a variable like int number. When you say equals and then 5, you assign this value to the variable. The process is that simple. Nice. Is that all there is to it? That's the structure. There's nothing extra or very detailed. Alright, let's try it. I said integer number. Now I've written this, defining the variable, the type of the variable, the name of the variable. Then, when I say equals 56 to this variable, I'm assigning the value. That's it. There's nothing else. When I say system out and then number on the screen, I'm writing it like this. Let's see. Let's run it and see what appears on the screen together. The number variable is 56. Very nice. Teacher, okay, you wrote it like this. But what if I copy this and want to print it out here? What happens? So, would it work if I used it like this before you assign a value? No, it wouldn't, friends. Why not? Now, when you hover over this meaning, when you move your mouse over the part that's underlined in red, it tells you that you haven't initialized this number. Look, let's hover over it like this. What does it say? This variable. So, this is a variable. It's saying that our variable hasn't been initialized. What does it mean for it not to be initialized? Friends, when you define a variable, it needs to be stored in memory so that its existence can be recognized. There needs to be a place in memory, a value assigned to it. Now, unfortunately, there isn't a specific memory region that this variable points to. In other words, there's nothing from which you can actually read a value. So, since it doesn't exist, what do you have to do? You can't use it without assigning a value to it, so you can't use it here. It simply won't work. If you right-click and select Run, you'll see the error right away. So, that means we can't use a variable without assigning it a value first. Now, this approach is correct within a method. This usage, guys, this error inside a method is a valid error. But when we change the definition of the variable, when we move it to a different scope, for example, when we define it inside a class but outside the main method, things change a bit. In such a definition, meaning, when you define a variable inside a class, you don't need to initialize it. It will already be allocated in memory. We'll get to these later. In other words, we'll talk about the scopes of variables and where they can be used and defined. There's time for that. So I don't want to confuse you too much here. For now, it's not possible to use a variable defined inside a method without initializing it, guys. So, are there other assignment operators? Are there other types of assignment operators? Yes, friends. These work within a certain logic. You can define these at a certain level of logic. Now let's reinforce and clarify this with an example. Now look, integer. I say S1 equals 6. Now let's print this number to the screen. S1 plus S1. Now this is worth 6. So I want to add 5 to this variable S1. So I want to change the value of variable S1 from 6 to 11. I'll add 5. Look what I'm doing now. I say S1 variable equals S1 plus 5. Now, this logic, the way it looks right now, seems so meaningless to you. I can define it like this. For example, in mathematics. In mathematics, 6 plus 5 equals 5. Now, does this make sense to you? No, teacher, what does that have to do with anything? The answer is 11. It should be written like this. Right. But when you see it like this, what you actually get is something like this. So, what's the value of S1? 6. What's the value of this? 6. So, does that mean 6 equals 6 plus 5, teacher? No, guys. What you see here is an equality, an equals sign. Look, 6 plus 5 equals 11. But what you see here is not equality, it's an assignment operation. So, this means the following. It means, take the value of S1, that is 6, add 5 to it, and assign the result to the S1 variable. Now look, let's print the new value of S1 here and run the application. What did S1 come out as? Look, here S1 was 6, and it became 6. 6 plus 5 is 11. We assigned this to that. The new value of S1 became 11. Look, S1 is 11. This is an assignment operation, guys. So, is there an easier way to do this operation? So, there's an easier way to assign a value to a variable, in other words, to increase its value. Assignment with increment. Assignment with increment. This is the assignment operator, right guys? Equals means assignment, so what was the increment operator? Addition. It was plus, right? If you do plus equals, it means this. It actually means add this variable to this. To make appointments by increasing, so I say add. Look, let me show you completely now. What is the value of S1? 11. Now I say let's print S1 plus equals 20 to S1. Now, if this plus equals here is for incrementing, if its value is 11, it means add 20. So the result will be 31. I check, and as you can see, the result is 31. Well, teacher, if this is true for plus, is it also true for minus equals, times equals, divide equals, and percent equals? Exactly, guys. That's correct. So you can try them all. Minus equals 15. Let's print it out. What should we say? S1 times equals 3. For example, we can print it. Let's try it right away and see. Now I'm checking. Here was the increment. Look, this part is the increment. This part is 15. Subtract. It's 16. Multiply by 3. 16 times 3 is 48. So as you can see, it works with the same logic. S1 divided equals. What number should we use? For example, let's say 4. Guys, what will it be when we say 4? It will be 12. What's left? S1 modulo equals. What was it? It was 12. Let's make this 7 and print it on the screen. Let's see what results we get. Here we go. Look, it was 48 here last. We divided by 4, got 12. I took the modulo of 12 by 7. If I take 12 modulo 7, The remainder is 5. It assigns the remainder value to this. So this also became 5. So these are our arithmetic assignment operators. Friends, they perform assignment operations. Our basic, most fundamental assignment operator is always the equals sign. With the others, you can easily perform operations like incrementing or decrementing by combining assignment and arithmetic operations. These are codings defined for convenience, friends. We will continue with our next operator.